In this video, we are looking at Unit 6, Lesson 2, How Does It Change? So example 1, we are looking at the figure in the picture and how each expression represents the number of small squares. So, looking at this, expression A, there are 6 rows with 8 small squares, but from this, 2 rows of 3 small squares have been removed. Expression B, there are 4 rows of 8 small squares, and to this, 2 rows of 5 small squares are added. Expression C, this counts each row starting from the bottom. And then expression D, there are 5 columns of 6 small squares and 3 columns of 4 small squares. So each of them is a different way to express how many small squares are in the figure. And so just keep in mind there's many ways to write these. Here we are looking at example 2, patterns of dots. And so number 1, study the 2 patterns of dots and think to yourself, how are the number of dots in each pattern changing? And how would you find the number of dots in the 5th step in each pattern? So pattern 1, each step has 2 rows of dots, with each row having the same number of dots as the step number plus 1 extra dot. So in step 5, there will be 2 rows of 5 dots plus 1 additional dot. And then pattern 2, each step has as many rows and columns of dots as the step number. So step 5 is a 5 by 5 array of dots. Still on example 2, but number 2, complete the table with the number of dots in each pattern. So I've already done this, so try it for yourself and then unpause the video. But here's what I got. So the formula that you'll use for pattern 1 would be 2n plus 1, and then pattern 2 would be n times n or n squared. Example 2, number 3, plot the number of dots at each step number. So try it for yourself and then unpause the video again, but here's what I got. And so number 4, explain why the graphs of the 2 patterns look the way they do. The points representing the first pattern lie on a line because getting from one step to the next involves adding the same number of dots, which would be 2 dots. And the points representing the second pattern do not lie on a line, they curve upward because the number of dots added at each step increases from step to step. Okay, example 3, number 1, is the number of small squares growing linearly? Explain how you know. So no, because there are 3 squares in the first step, 6 in the second step, and 11 squares in the third step. So the number of additional squares is 3 going from the first to the second step and 5 going from the second to the third step. And then number 2, complete the table. Try it for yourselves and then unpause the video. Here is what I got. So your equation would be n squared plus 2. And then number 3 is the number of small squares growing exponentially, and how do you know? So no, because from step 1 to step 2 the number of squares doubles. From step 2 to step 3 the number of squares increases by a factor of 11 over 6. And from step 2 to 3 the number of squares increases by a factor of 18 over 11. These factors are all different, while for an exponential function the values increase by equal factors over equal intervals.